episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome everybody again to another episode of our show with another really fascinating guest helping to create a better tomorrow on so many different fronts. And if you're anything like me and you keep National Public Radio on during the day like I do here in the US, you no doubt have heard today's guest voice over the years talking about various topics going on at our National Zoo down in Washington, D.C., but now she has quite a bit more on her plate. Today we have the honor of being joined by Dr. Suzan Murray, who is board certified zoo veterinarian at the Smithsonian Conservation Biology Institute, SCBI, and serves as both the program manager of the Global Health Program and as SCBI's chief wildlife veterinary medical officer. Dr. Murray leads an interdisciplinary team engaged in worldwide efforts to address health issues in endangered wildlife and combat emerging infectious diseases of global significance, including zoonotic diseases. Dr. Murray also acts as the Smithsonian liaison to the Foreign Animal Disease Threat and Pandemic Preparedness subcommittee at the White House Office of Science and Technology. Dr. Murray's work focuses on providing clinical care to free-ranging wildlife, pathogen detection, advanced diagnostics, training of international veterinarians and other health professionals, capacity building and collaboration in infectious disease research at the human-wildlife domestic animal interface. She previously served as the chief veterinarian for the Smithsonian National Zoo and has a wealth of clinical knowledge and experience with wildlife and zoo animals, both free-ranging and in human care. Dr. Murray earned her bachelor's degree from Amherst College, completed her veterinary degree from Tufts University, and after a surgical internship, she completed a residency in zoologic medicine at the Smithsonian National Zoo and became a diplomat of the American College of Zoological Medicine in 2000. Dr. Murray has been either a principal investigator or co-principal investigator on numerous research grants, including Morris Animal Foundation, the Smithsonian Endowment, the Smithsonian Women's Committee, and James Bond Funds. Dr. Suzan Murray, thank you so much for taking the time out to schedule to come on the show.
It's my pleasure, and thank you for that great introduction. I was following along. I'm like, wow, that sounds like a terrific job.
Someone you know.
Right?
Absolutely. Absolutely.
Yeah.
You know, this is I want to, keeping along those lines, I sort of want to hand things over to you like we typically do at the beginning of the show, just to go a little deeper into your background. If you could take us for a few minutes, a little bit on your journey, everything from where you grew up, how you got interested in science and veterinary medicine, and a little bit of your journey to date. I think that'd be a great way to start everything off.
Sure, I'd love to do that. I grew up in Port Washington, Long Island, and my mother grew up on a farm in Germany. So we spent a lot of time growing up on a farm, which I think really helped my love for animals. My father was worked for IBM, and he was all into math and sciences. And I think that conglomeration of, at a very early age, of trying to bridge love of animals and math and sciences brought me to a place of knowing very early on that I wanted to study veterinary medicine. And there was also another compelling thing. I loved National Geographic growing up. You know, we watched it all the time. And I remember one very memorable show when I was watching with my dad and Jane Goodall was on. And I said, you know, I was about 5 or 6, and I said, Dad, that's what I want to do. And he said, okay, all right, then that's what you'll do. And I think in my mind at that point, I was just like, well, if Dad said it, it must be so. Sort of like if he said the sky was orange. I mean, it's just that thing. And I, at that point on, I just knew that that's where I was heading. And it gave me a lot of comfort during the years when a lot of people were trying to figure out what they were doing with their lives. I kind of knew, right, that's what I was going to do. And perhaps comfort mixed with a little bit of a lack of introspection. I just followed that path, and you know, with course corrections along the way. And during the veterinary school, I had the honor to actually go to Tanzania and work with Dr. Goodall, and she was my thesis advisor. And it was this terrific coming a full circle. So I'm like, well, you know, Dad said that's what I was going to do, and here I am. And so I think that one thing built upon another, and as you move through life, you take the opportunity, you work hard and take the opportunities that are afforded to you. And that's what I did and continue to do. So I think that's the best summary of my background and how I best got here. Absolutely. And one of the things I tell young folks a lot, because there's a lot of up and coming students who want to get into helping save the world one way or the other. Like this next generation, man, these guys are energetic, they're thoughtful, they're strategic, and they know what they want and they go for it. So it's really a pleasure to be able to help advise these youngsters coming up, and just, work hard and keep going for it. Go for that which you are truly inspired about. I would say that I've always known that I would be contributing to the health of endangered species in the wild. I've always known that I would be doing that. I did not know growing up that I would have an opportunity to help participate in emerging infectious disease and development or research and pandemic prevention. So I did not know I would be able to contribute to another one of my favorite species, humans. So it's quite an honor to be here and to be in the situation where you get to go to work every day knowing that you're truly working to make the world a better place and save both human and animal lives. I think it's an incredible opportunity and an amazing honor. And for me, where else could you do it but where I am at Smithsonian? So that's a great honor too.
Yeah, I can imagine. It's a fun place to work, most definitely. I enjoy going to the museums, so I definitely, and the zoo.
Yeah, and if you're going to be looking at a place where you can always learn something, being in a museum or zoo setting, there's always something to be learning. You're surrounded by really terrific, hardworking, and dedicated people. Mm-hmm. And then Smithsonian's mission, is to increase and diffuse knowledge. Yep. By definition, you're always learning and always contributing.
Outstanding.
Right.
So, yeah, I mean, before we get to I want to start somewhere else than zoonotic. We'll go to the zoonotic diseases a second, but I want to start actually. I really enjoy reading your papers, and they come with these fascinating themes like epidemiology of clinical feline herpes virus infection in zoo house cheetahs, diagnosing cardiovascular disease in western lowland gorillas, and with brain natriuretic peptide. There's a little sad one here on surgical castration of capybaras, but really fascinating range of topics. And I sit here in Philadelphia. We have a zoo, a really nice zoo that I get to. And I've always wondered, when I look through your materials and I think, when you sort of trying to figure out what to do on a given day, and I know you have specialists, you're the primatologist and the herpetologist and so forth. Is it more like a hospital setting where the tiger has a rash and the alligator has diarrhea and there's problems here, or is it more like a pharmaceutical company where there are these big issues, whether they're heart disease or cancer, and you focus the research in sort of these larger issues that may affect a variety of species at the zoo? How does it typically work? How do you set your priorities?
Oh, that's a great question. I'm going to say it's a combination of that. So in my previous role as the head of the hospital at the zoo, I was in charge of the clinical care of the animals. And in that case, you have a day-to-day, you have a team of people and, the veterinarians, technicians, pathologists, and the people that do the frontline care of animals, keepers and curators, that work together as a team to decide, the tiger has a rash, what do we do about this? The flamingo has has a tumor, or these sorts of things. And there's a lot of sort of day-to-day things that you would expect to see and that you treat as perhaps one-off, that's not, a cheetah with a skin wound or something. It's not necessarily of major import to the population or the wild population. But every now and then you see things that come in patterns or seem to have, several of these things, like, where you think, this is different and it's more than just one or two. There's actually a theme going on here. I should also add in that the American AZA, American Zoological Association, has a number of different types of programs, one called SSPs, Species Survival Plans. And so SSPs within the AZA, and each of these have veterinary advisors and nutrition advisors and pathology advisors. And that's to help genetic advisors help to manage endangered species throughout all the associations that are registered within the US. So that gives us a ready-made team, and it's small enough that we all know each other. So if we're working on something with gorillas and we see, oh, this gorilla has a type of heart disease, or dies of it, we have pathologists who really look into it and help determine the cause of that. Then we check in with the SSP and say, have you seen this before? And if it ends up being a broader issue, then we all work together to say, well, how do we best tackle this broader issue? And that's exactly what we did with gorillas and cardiac disease as well. Dr. Haley Murphy from Atlanta, Zoo Atlanta, is the one who first started pulling all this information together on gorillas and cardiac disease. And if you think of it, with humans, you've got millions and millions of samples and examples of normals versus abnormals. So you can really get data very quickly, whereas with zoological animals, especially endangered species, there's fewer of them. So it's really important that all of us that have them in our collection work together very carefully to identify issues and address them. So I think that's a way that, in addition, in your day-to-day work, you see cases come and go, but as part of a larger community, we work as a group to say, oh, this looks like it's a real issue. And then we say, well, who's got what capabilities, what grants do we write? And then what do we do to, make sure we're having an impact taking care of animals? I think the cardiac issue in great apes is really fascinating. It's one of the primary causes of death in male gorillas, and similarly in humans, there's a heart disease is a primary cause of death. The illnesses are similar but distinct, which I also find fascinating. Whereas humans, the illness is largely involved with the coronary arteries. And in great apes, its cause of death is often fibrosing cardiomyopathy, where fibrous tissue gets laid down in the heart and disrupts the electrical impulses. So I find things like that, and the relation between animals, the similarities and the differences, just fascinating. And you can learn so much and apply so much. Like human medicine has these wonderful techniques that we sometimes borrow to help care for animals under our care. And then in my current position with the global health team, one of our big goals is to take what we learned from animals under care and apply it to the wild. So go back and forth with our programs in Kenya. We collect information about Cory bustards, again, that largest flighted bird, and learn about it so we can take excellent care of those animals here at the zoo, and then vice versa. We just finished another study, a new publication, which you would not have a chance to read just yet because it just came out a week or two ago. And that's looking at long-acting antibiotics in cheetahs. And so the idea is, if you have a cat or a dog or a human that would ordinarily take an antibiotic when ill, like twice a day, if that's the regular dosing regimen, and you're in the wild, and the wildlife veterinarians either have to find that cheetah every day to dart it or bring it in captivity, neither of those are really good outcomes. It's very stressful for the cheetah and very time consuming for the wildlife vets. But one of our thoughts was, well, if we could work on these long-acting antibiotics and see how they behave in different species, we could really be contributing a lot to wildlife care. So one of our veterinary fellows, Dr. Jen Yu, just published the paper showing that this antibiotic, cefovicin, can last and maintain appropriate values against the majority of pathogens for more than 10 days after one injection. That has huge implications for how we might treat cheetahs in the wilds, and certainly how we might better manage them in captivity. So, not all of our research papers are focused on, gee whiz, I wonder why this happened.
Mm-hmm.
A lot of them are, but a lot of them have real practical applications, like why did this happen? And then what can we do about it? And how can we have results that are directly applicable to saving lives, cheetah lives in this case.
Outstanding. And just, you know, while we're on this theme, because you and I talked offline a few weeks ago about the fibrosing cardiomyopathy in gorillas, and I happened to have been a lifetime ago in at Rutgers University when we were studying Aphromomum melaguta, the
ginger.
The
yes.
ginger, yeah, the ginger
yes,
variety that they, you know, found in the Western lowland gorilla diet and so forth.
Yeah.
They weren't getting, and had some very interesting mechanisms in terms of lowering C-reactive protein, other sort of pro-inflammatory cytokines. The theme of zoopharmacognosy is always very, pharmacognosy in general is very fascinating, but the concept that you know, there's more than just oh yeah, the animal that feels sick and chews on something over here, but there is some almost this instinctual, this sort of evolutionarily perfected dynamic out there. These animals have been there quite a long time, learning from nature. Any other interesting zoopharmacognosy related findings? I don't know. I know this is not the core of what you do, but when you were talking about the gorillas, it just made me think about it. So I wanted to bring that one up now.
I've actually never heard that word before, and I was going to ask you if you made it up. It's wonderful.
Yeah, it's a cool word. No, I didn't make that one up. Yeah.
Yeah, no. I think it's a wonderful word, and there really is so much that we don't know. And you know, and when people ask, you know, about one of the reasons, like we all like our job so much, it is like the more you every stone that you uncover, there's more and more to learn. And I think what you just said is a really good example too of how there's so many reasons to help keep animals alive in their natural settings. But that's another reason to actually help keep them alive and study them, because as you said, a lot of these species have been around a long while. They've learned how to survive. And there's lots and lots of different things that we can learn about from plants and how they might affect human health as well.
Very good. So, Suzan, back in, I think it was 2016, you gave a presentation at the World Economic Forum. It was entitled "How to Stop Pandemics Before They Start." You know,
right?
So we are here.
That was a good title.
5 years before, but so here we are in the middle of a major pandemic, and you know, there was this sobering study by IPBES, biodiversity, the world, sort of the report on biodiversity and pandemics. About a few months ago, this sobering estimate of 1.7 million undiscovered viruses thought to exist in either mammals or avian hosts, and somewhere between 600, 800,000 potentially having the ability to infect humans. Mm-hmm. We're in the middle of one of them right now. Spent a little time about a year ago with Lin-Fa Wang down in Singapore talking about bats. You at the SCBI have a bat program in Myanmar. You also recently published on some of the zoonotic work in Kenya, looking at bushmeat exposure, things like that. Talk a little bit about what you have. I know this is the core, really, of sort of what you're doing with the Global Health Program, but talk a little bit about what you're doing today and some of your future visions in terms of the zoonotic pathogen work.
I'd love to talk about that as well as and tie that into our training programs, because a lot of our international vet training programs are the core of what we do as well, because there's so much that needs to be done, and it's really essential that we work with the communities that are most at risk, and then build capacity within those communities and within those countries to help address some of these issues. You know, while we're at it, I'm not sure if you saw it, but on Smithsonian Channel, it was just like 2 weeks ago, a new video came out that has both our team and Lin-Fa Wang in it. It was called Virus Hunters, you know, from Cave to COVID. Yep. I understand, I haven't seen it yet, but I understand it's really great. So I'll mention that as well.
I haven't seen it either, but I saw someone post something about it. So yeah, I'll watch it too.
Yes, in any case, I think that referring back to that talk at the World Economic Forum, First and foremost, I have to say that I'm a member of I was very happy to have the chance to speak, and I'm a member of a larger consortium that has been studying emerging infectious diseases for a while. We had a program that was funded by USAID called PREDICT, and it was led by the University of California at Davis by Dr. Jonna Mazet. So she really was the brainchild of a lot of this and got our 5 institutions together to address these issues. I think one of the new things about our approach is that the groups that she got together, we were all veterinarians. And I think that, and one PhD, sorry, but I think it represented a novel way of looking at things that prior to this, maybe decades ago, veterinary medicine and human medicine often went side by side to each other, like in parallel, not necessarily working together, perhaps borrowing a little bit from each other. And a little bit over a decade ago, the thought paradigm of One Health that in order came up, the idea that human health and animal health and environmental health are all very much intertwined. So that was a lot at the basis of this program. And it was based also on the knowledge at that point that epidemics and pandemics are coming more and more frequently. And one of the things we wanted to find out is several things. If we want to be able to study and prevent, first we needed to know what viruses are out there. Because if you think of it, if we, like even in an Ebola situation, if it happened in a vacuum, meaning just people started dying, and then you try to go in and investigate and perhaps then build the laboratory or support the laboratory capacity and create the PCR diagnostics and try and figure out which virus it is, and then backtrack and figure out, well, what species is the natural host of this virus, and do the wildlife surveillance at that point. And then add the behavioral component in. Well, what are people doing to put themselves in harm's way? You've lost hundreds of thousands and now perhaps millions of lives, billions of dollars, and wasted months, if not years. So part of the thought was to get way ahead of this and see if we could work as a team with MDs, D.V.M modelers, ecologists, economists also, and to look at, well, where are the hot zones in the world? Like, where are the places that are most likely, based on the data that we have, to have an emerging infectious disease? And then we concentrated in those countries, and we started trying to find out what viruses are already present. If you think of it, if resources were limitless, we would be looking in every country and every species. And if you're going to operate on, with limited resources, then we do have to prioritize. So that was we used modelers to help us prioritize which countries we should spend time in. And then also we had geneticists and phylogenists who would look at the relation between different wildlife and humans. And we found that while there are many different species that could transmit illness to humans, bats, primates, and rodents are the ones that are most likely to carry a virus that could really kill a lot of people. So we spend a lot of our time identifying, trying to get information from those animals. But we also have to do it in a safe and a humane way, so we're not going to another country and injuring their wildlife. Mm-hmm. So another part of the plan was in each country in which we worked, a country coordinator from that country was hired as a major partner to help organize and figure out where we should go and where the threats were in those countries. And then we developed a wildlife surveillance team, and we built a lot of capacity and did a lot of training. The US is very fortunate that we have a number of great institutions that teach about advanced care of wildlife and really all species. So we were able to utilize a lot of this knowledge and transfer that to the other countries in which we work, so we could get the information. But then once you have the information in the field, you have to get it to the laboratory in a safe way. So there was really a lot in these processes that we would help move forward. And then also there were teams of virologists, because even though we identified over 1,000 viruses, not all these viruses necessarily are going to cause a big problem for humans. So then the virologist would rank those based on which are the families most likely to have a problem for humans. And by the way, that paper just came out 2 days ago. It's called Spillover, looking at a way of ranking the viruses. So anyways, that's a long way of saying it was a long thought. I mean, it took a long time, but it was a very organized way of not only building the capacity, but identifying viruses. And now we know that we have less than 1% of those viruses identified. So there are other teams as we look into the future that are looking at a number of different things. What are the areas where we're stopping spillover or hoping to stop spillover? How can we best characterize viruses? One of the things that we're looking at, particularly in Smithsonian, is how do we look at the science and health in the context of culture and art and science all at the same time. I think that's one of the great, and ethnography as well. I think it's one of the things that Smithsonian can do. We've got all these top-notch people in all different fields, and it's an exciting time for us to all come together. Like folks from the Air and Space Museum and looking at satellite images of how land use changes. That's one of the primary drivers of disease emergence, how land use changes. And if you can look at these satellite images over a period of years and decades, you can not only see where land was changing most rapidly in the past, but you can predict how it might change in the future. So that's one of the things I'd have to say that I'm most excited about, that we are working with, again, Air and Space Museum. We have a wonderful ethnographer from the Museum of Natural History as well, because if we want to be successful, you know, we need to start and end with the community that's most at risk, right? We don't want to come in as a bunch of foreigners and say, oh, you shouldn't do this and you shouldn't do that, right? But working together. And then we've got these tremendous labs to help identify the viruses and these great communications and PR teams and shows to help share the knowledge. And then the last part I'm going to say, which I really love, is another part of Museum of Natural History. There's an outbreak exhibit, so the public can go and learn about illnesses, but you can also, we can customize these panels for different countries based on their risks and their communities as well. And then they can go on the road to the communities so we can share what we've learned. So sorry, it's a really long way of saying there's a very complex story with a lot of moving parts. And I think the place I get most charged up about is when that comes together, when everybody says, oh, I can do this and I can do this. And we have this great program in Kenya already that we could then replicate in Asia and then with our folks in Panama. So every time I think, wow, we've just made this huge step forward, we realize, oh, there's a whole bunch of other really big steps we can make forward. So anyways, I've jumped ahead just to say which I'm really excited about, but maybe we could talk again in like 6 months or a year. I'll give you another update in terms of, well, this is what we've done already.
Yeah, it's no, it's extremely exciting, and I'm glad you're behind this. And I mean, it's clearly, you know, we talk about in sort of my other job is in the biotech world, so these tsunamis that are coming of dementia, Alzheimer's, and so forth. This is a big tsunami. I mean, if there's that many viruses out there, and even a small chunk.
Yes, it's crazy. Oh, I should also mention there's another nonprofit, Global Virome Project, which is looking at just that, which is, you know, the Human Genome Project.
Right.
Which I worked on as a technician in Boston years ago, like decades ago. But now we're trying to do the same thing with viruses, because if we're going to understand the viruses and try and understand the spike proteins and provide the information to pharmaceutical companies to build the vaccines, we really need to get out there and get the libraries of all these viruses. The ones that are not pathogenic, the ones that are pathogenic, put it in an open source area so everybody can get access to it, and save the world from the next virus.
While we're still on this topic, I was just, one of the things that when I talked to Linfa about, we got on the topic of the Hendra virus, which extremely deadly, doesn't kill a lot of people, but infects a lot of horses. And he came up with, this strategy of vaccinating the horses, and they took care of the Hendra. I mean, I guess it's kind of difficult, but you can't, go out and vaccinate all the hippos or something if there's a if there's a hippo, the intermediate species. But is that part of sort of the intermediary species? And we're searching for them now, but when you do find them, are there strategies to sort of, hey, should we ever vaccinate this, that, and the other thing as a way to prevent?
Yes, and I would say there are so many of these young, brilliant minds who are coming up with strategies like that. And there's like different challenges where people can throw their ideas in and say, what if we did this or that? We have something a little bit along those lines. So in Kenya, rabies is in many different places, rabies is a very worrisome virus that causes disease and death in humans and animals. And one of the things that we had first done in Bolivia, where there's an endangered wolf, the maned wolf, we went around to the villages on the outside of the park, and we vaccinated the dogs against rabies. So that's nice, and we and dewormed them. So the villagers then get a healthier animal, and that kind of it breaks down on the transmission cycle. Now, we started, one of our colleagues, Adam Ferguson, and then our Kenyan colleague, D.V.M, in Laikipia, which is where Impala is based, started a vaccination campaign. And they started it, I'm going to lose it now, like 6 or 7 years ago with, why don't we see if we can vaccinate like 500 dogs in this area? And over the last 5 years, it's grown to, and this past year, over 17,000 dogs were vaccinated in Kenya. So that is an example where if we can really do that effectively, but vaccinate the dogs who often can transmit the rabies virus to wildlife and to humans, we could theoretically break that chain. So that's an example of where a host, by using newer techniques, we can break a chain. There's some other things that we can do, again, a little bit more remotely, and this is more in terms of diagnostics. But if we think of mosquitoes, not only as the pests that bite us, but almost a little bit like flying hypodermic needles. Yeah. Our folks in the microbiology laboratories can, if we get them these mosquitoes, can not only determine what type of mosquito, but from the blood meal, they can determine who the mosquito was feeding on and what pathogens that animal or person might have. So if you think of it, there's so many different things that can be done with that. Mm-hmm. It'd be a great way of conducting surveillance as West Nile moves forward, or really any vector-borne illness moves into an area. So it's a way that even before people start getting sick, we can say, oh, this virus is now in this community, and we can preempt it. And then some other things we're looking at too is having, in addition to doing both human and animal syndromic surveillance, meaning finding an area where we think is going to be a high-risk situation, and then setting up programs, working with MDs and nurses and veterinarians and the country, of course, government officials, to monitor human and animal illnesses. And we're working to put that on a smartphone app. So it can be reported very quickly, and then we can develop, we're in the process of developing a rapid response team. So ideally, we can use a number of different things. We can use the remote sensing of the satellite images. We can use the mosquitoes and the surveillance system of what the mosquitoes have in their blood meals. And then syndromic surveillance of both animals and humans on a smartphone to take this information in and then respond quickly to when people or animals start dying, and then get that information to laboratories, and increasingly build the role for veterinary pathologists as well, because there's so much information that we still need to gather. So I guess that's there's another long answer to your question. There's just so many.
They're great answers.
Right? It's a great question then. That if it inspires that much thought, but I think that my point is there are so many people doing so many different things, and the great thing is that people really are, I think, from my perspective, really very interested in working together and seeing how we can all pull that together. So our Predict team, the team that did the first 10 years of that USAID grant, were pulled together again for another try at a large grant to make, to work together to make the next huge step forward in characterizing viruses.
Gotcha. Really cool.
Yeah. Oh, should I tell you about the training programs while we're at it?
Sure. I know this is an important part of what you do. So please take the floor.
Thanks. That's a really important part for me, because I think that we have so many, as a veterinarian here in the United States, and had great fortune in having access to a lot of places to gain information, a lot of great equipment, partnerships with hospitals like children's hospitals where we share knowledge about animals and humans, right? And to be able to, but not every country has those same, people with the same access to information. So one of the programs that we work on is an international veterinary exchange program, where we bring people from other countries to spend some time at Smithsonian. And then we develop a specified learning plan based on their interests. So if it's someone who's really interested in rhinos or bongos, they can spend 1 week with the clinical vets, 1 week with the pathologists, 1 week with the molecular diagnostics team, and then another week with the global health team and developing research projects. And then we also send folks from this country to other countries as well. This past year, just before the pandemic, we ran an advanced medicine course for rhinoceros in Kenya. And it was really, we partnered with Kenya Wildlife Services, and we had veterinarians from all over come presenting and learning. And I think that's the key of everything. No one's got the whole picture, right? So everyone has something to give, and everyone has something to learn. And then the other part of that is in Kenya also, we've been pairing veterinarians, like an American veterinarian with a Kenya veterinarian for a year at a time, with the idea that both have a lot to offer each other and both have a lot to learn from each other. So it's not one person parachuting into another country saying like, this is how life should be, but coming over and being a guest and asking and learning, and then also sharing knowledge. And then, so while we've been working a lot on specific veterinary techniques and modalities, the more that we can now branch out and practice our work again in context of how art, science, and culture are all very closely intertwined is really the next exciting step for us.
Absolutely.
Yeah.
While you brought up both Kenya and rhinos there, and I just wanted to put this one in at this point, because I think it's an exciting project, a set of projects looking forward. Obviously, in Kenya, you are doing a lot of things in terms of rhinoceros health, and you focus on a range of different rhinos: the white rhino, northern white rhino, eastern black rhino, southern white rhinos. I had the honor of talking to Thomas Hildebrand over at Leibniz last year. I was working on impregnating the one of the only species left in the world of the northern white rhino. Talking for a couple of minutes about technology, emerging technologies, whether it's IVF, cloning, some of these new tools that are coming down the path, what you're excited about, what you're not excited about, but talk a little bit about that in terms of conservation by some of these sort of biotechnologies.
Oh, there's so much. So I'm so glad you spoke with Thomas. He is brilliant, innovative, hardworking, fun. And he did a lot of his initial work here at Smithsonian's National Zoo with my favorite elephant, Shanti, who just passed away this past year, but she was an incredibly, she was a very smart elephant that had a very close bond with the keeper staff. And she loved them like crazy. And she also was very responsive and pliable. So it was easy for, she was a great person for elephant for Thomas to work with and develop some of his techniques. Even when he would visit years later, Shanti would be very happy to see him. So he's another example of someone, he and the rest of his team are very innovative and are always thinking of learning a lot and thinking of different ways to help breed animals. So yes, they were just down at Old Pejda working on the white rhinos. And I think, you know, his ability for ultrasound examination is amazing as well. Because if you think of an elephant or a rhino, they're kind of this big giant gray box, right? You can't really get an X-ray in there, but you can learn an awful lot and can do an awful lot by ultrasound. So I'm continually fascinated and in awe of their team and really happy that we get to work with them from time to time. In terms of rhino research, there's a lot of different things coming up, and there is, even just trying to manage endangered species in the wild takes a village. There's a lot of groups that we work with very closely. Old Jogi is a conservancy that's close to Impala and Old Pejda that hold a lot of rhinos, and so we work closely with them as well. One of the things we've been talking about is also helping to working with Kenya Wildlife Services to utilize some technologies to understand how rhinos and elephants might move in a way that could theoretically outfox poachers. And which again, if we can make that work, I'd be very excited about that. The idea behind this one is novel as well, which is if you put a transmitter on an elephant or a rhino, you can see where they're going. And if you put it online, well, so can the poachers, right? So, you know, so there's someone is always going to be able to outfox you. So, so animals indeed can be tagged and collared. One of the things we're looking at is that animals tend to move. I'm going to speak in generalities right now because we don't have enough data to say specifics, but animals tend, the animals that live around rhinos and elephants, like zebra or gazelle or giraffe, tend to move differently if they're all alone and no one's around. If there's a human or a set of humans on foot, like herders walking by, or if there's someone like poachers sneaking after them. So in the first time, if you're looking at everyone's movement, they might just be moving almost like a Fitbit, right? Moving 3 miles a day or 2 miles a day if they're not disturbed. And if they're disturbed by people they see all the time, like herders, they might move 4 miles that day. And if they're being disturbed by someone who's, you know, sneaking around furtively or trying to, you know, it's like a poacher, they might all of a sudden sprint somewhere different. So so part of the idea is for us to be able to put collars and tracking devices on everybody, like not every animal, but subsets of animals. So gazelles and zebras and giraffe. So when the gazelles all of a sudden start acting in category 3, they're seen, so maybe we might be able to use, our hope is to be able to use the behavior and movement of other animals as an early warning system for when poachers might be in the area. And then we can, again, all of us would be in partnership with government officials in Kenya Wildlife Services, or whatever country that we are successful in putting it in. But then the management people would be able to say, oh, there's a lot of activity in sector 1, you know, but we don't have any rhinos there, we're okay. Or look at all the animal movement in sector 4, that's where the breeding rhinos are, we need to get there right away. So in the whole idea that knowledge is power, and the more that we can harness, utilize our existing resources to harness additional data, especially if it's machine learning or, you know, that can, or at least provide information rapidly, the more we can do to provide information rapidly to our partners in other countries in developing or in different nations, on both animal and human health, the more successful we'll be in helping save the lives of endangered species and humans. So that sounds like a great idea, don't you think?
Yeah, most definitely. Most definitely. Wonderful stuff.
Yeah.
Suzan, this is now the fun fact part of the show. In researching everything about you and your papers and your background before the show, I learned something I never knew. I don't know how, maybe no one knows, maybe only a few people know, but tell us about who James Bond was, the ornithologist.
Oh yeah, because we had the James Bond.
For a second, when I was, so I'm looking, I was initially reading, I was like, wow, she's sponsored by James Bond Fund. She was doing some espionage things or whatever. But no, this is a really cool story about an ornithologist named James Bond who gave Ian Fleming sort of the idea for the character. Tell us a little bit about that.
Wait a second. Did he give? All right, so I knew about James Bond, the ornithologist, right?
Yeah.
And we definitely. I was very happy to have received money from the James Bond grant, and we did use that in the Caribbean for studying iguanas, and so very excited about that. But I didn't know there was any connection between my James Bond and their James Bond.
Okay. Yeah. So, okay, I'll give you the fun fact then. Yeah. So in researching this, it was the ornithologist James Bond, who named the James Bond Fund's named after, and yeah, he was down there doing educational extension and so forth, and studying birds in the Caribbean and so forth, and he was kind of a cool dude. and Ian Fleming, I don't know how Ian Fleming met him or read about him or whatever, but that's where the idea came from for the movies. It wasn't any CIA sort of British intelligence thing. James Bond ornithologist hanging out in the Bahamas.
That is crazy, and I'm so glad you shared that, because it's these kind of things like especially now when we're hoping that the end of COVID is coming and we'll begin to be able to socialize again. It's a kind of fun fact I'd like to be able to pull out of my my back pocket. What are the 6 degrees of separation between me and James Bond?
There you go.
Wow. Yeah, well, thank you for that. No, I didn't know that at all.
Final, let's see, wrap-up question here. I've got just a couple short ones. Typically we ask a question about sort of influencers, mentors. Obviously, you've met thousands of people in academia and government and industry over the years. If you want to take a couple minutes just to shout out to anybody, I'd love to give you the floor again as we take this episode out. But please talk about some of the ultra important people that have kept Dr. Suzan Murray on this path and passionate about it until this very date.
I would say that sometimes you don't recognize who a mentor might be or an important part in your life until afterwards. So I would say that certainly my dad early on, who was always always be thinking and always be, improving things as best you can. Dr. Goodall, without a doubt, she's incredibly inspirational. And I think she's one of I've told you, she was when I was 5 years old, she was the one that made me feel like this is a thing that we can do. And then there's my daughter, Jamie, who is currently a student at Lewis and Clark in Portland. Nice. From a very young age, she was very much a strong feminist. And I don't think I had a sense of what that really meant until I had her as a daughter. And so I feel like I've learned a lot from her, and she's helped me think of not only what I hope to achieve in life, but helping others, helping other women, but helping support everybody, not just women, but anybody of an underrepresented group. I think that, and I've really learned through her that the more diverse opinions that you add to a team, the stronger you are. And so I've learned a lot about diversity. and the important, and the not just that it's important to embrace, but really the value of really embracing all and supporting all voices. And then to finish it off, there was two amazing women at Smithsonian who early in my career really struck me. Evelyn Lieberman, who has since passed on, and then Dr. Eva Pell. These are two incredibly smart, hardworking women who I looked up to from the beginning, who I think could be very direct, sharp at times, super smart, but funny and warm at the same time. And I thought, wow, I think maybe there is a place where you can be female and directed and warm and smart and funny and all these things. And so I think that having those two, so neither of them are still at the Smithsonian, as I mentioned. Evelyn has passed on, and Dr. Pell is retired, but I hang on to them in my mind of thinking, I wish when they were still here, I had recognized the importance of their mentorship. But you know, I'm recognizing it now, and I think there's a lot of folks I'm learning from.
Thank you for sharing that. It's a wonderful message, and yeah, I mean, this is a fascinating portfolio of things you're still working on, Suzan, and it's really amazing. I'm wishing you the best with all of this, and I think, you know, everything you talk about sort of epitomizes, you know, not just you know, how we can help wildlife, being one species on this planet of millions, but at the same time, that nature, the natural world, has so much left to teach us, and you know, what we can learn today, where we're going, and it's really fascinating. And you know, I want to thank you for taking the time to talk to us about these issues. For everybody that is going to be listening to this episode on the podcasts or watching on the YouTube channel, you've been listening to the amazing, multi-talented Dr. Suzan Murray, Program Director of the Global Health Program, Chief Wildlife Veterinary Medical Officer at the Smithsonian Conservation Biology Institute. She is also the Smithsonian liaison to the Foreign Animal Defense Threat Pandemic Preparedness Subcommittee at the White House Office of Science and Technology. Suzan, once again, thank you for taking the time out of your schedule to do this. Thank you for everything you're doing down there in Washington. And as we say on the show, thank you for helping to create a better tomorrow through all your initiatives. It's really great stuff.
Ira, it's been a real pleasure. I appreciate you. I appreciate your show and the chance to share what we do. So, and it's been fun. So thank you so much.